All right, so what we're looking at in this one is that we're going to be looking at what's called the theorems about roots and polynomial equations. So there's going to be some writing in this, and it probably won't make sense, but hopefully I'll be able to explain it well enough so it makes more sense than you trying to read it. So here we go. So the rational root theorem. The rational root theorem states that if P over Q is in the simplest form and is a rational root of the polynomial equation, blah, 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 and the integers are the coefficient, then P must be a factor of AO, and this is the other one. So basically what it's saying in very formal type math phrasing is that if you have the equation, let's say 2x squared plus 4x minus 8. Okay, let's say you have that. It says that the let's change this to 7 just to be different. It says that the rational roots, if there are any, must form the fraction P over Q. Okay. Now your Q is the first number and your P is the last number. Now what you're going to have to do is you're going to have to find all the factors of the first number. So the factors of 2 are 1 and 2, but plus or minus. Okay. Your factors of Q are all going to be plus or minus. The factors of 8 are 1, 2, 4, and 8. Now your answers, or possible roots, are the fractions that are formed by taking the last number divided by the first one. So we'll start with this one. It would be 1 over 1 plus or minus. We have 1 over 2 plus or minus. We have 2 plus or minus over 1. We have 2 plus or minus over 2. We have 4 plus or minus all over 1, and we have 4 plus or minus all over 2, and we have 8 plus or minus all over 1, and we have 8 plus or minus all over 2. So it looks like the numbers, once you reduce all these fractions, we'll do them in orange, we're going to have plus or minus 1 is one possible, plus or minus 1/2, plus or minus 2. You see this one is also 1, so we only have to put 1 once. Plus or minus 4 for the next one. We have a plus or minus 2 again, that's a repeat. Plus or minus 8. And then the last one you see is also plus or minus 4 again. So these are the possible roots, rational roots that you have. Okay, so as you see, there's a lot of them in this one. In a lot of cases there are. So now let's look at this one. If you look at this one, the first number is 1. Okay, our factors of 1 are plus or minus 1. And the last number is 3. Factors of 3 are plus or minus 1 plus or minus 3. So the only possible solutions, rational roots we can have, are either plus or minus 1 over 1 or plus or minus 3 over 3. So 1, negative 1, 3, negative 3. Now what you're going to do with those is that you're going to plug every single one in to the x until you see one of them comes up with a 0. So as you see here, here's the numbers. This is 1 being plugged in to every single one. Here's 3, negative 1, and negative 3. And as you see, when you plug them all the way through and you solve, what you're trying to do is you're trying to identify which one equals 0. And we see it's got to be this one. So one of our rational 0, our only rational 0, which is a nice round number, for that original equation is negative 1. Okay, so negative 1, x equals negative 1 is the only rational 0. Okay. Now that doesn't mean it's the only 0, because we can have imaginary or stuff with roots. So we know the rational 0 is -1, and all you have to do is find 1. Once you find 1, you can use synthetic or long division to help find the others. So what we're going to do is we're going to divide. If the root is -1, that means our original equation would be x plus 1. And so now I'm going to use synthetic division in this case, and we'll do synthetic division in red. And so in the box we're going to go -1, and then we write out the coefficients, 1, 1, -3, -3. Now, if we did our first calculation right, and this one, we should get a remainder of 0. So again, drop the first number. -1 times 1 is -1. 1 plus -1 is 0. -1 times 0 is 0. -3 plus 0 is -3. -1 times -3 is 3. -3 plus 3 is 0. So as you see, we have a remainder of 0. In our function, we're going to have x plus 1 as one part of our factor, and our other factor looks like it's going to be x squared because we dropped the power by 1 minus 3. And now from here to find the other 0, you just set that second equation, this one here, set it equal to 0. X squared minus 3 is equal to 0, which means x squared is equal to 3. Take the square root of both sides, which means x is equal to plus or minus root 3. And that would be our other 0 in this case. Okay. So we know this is a 0, -1, and now we know this is a 0. So what the rational roots does is that it helps us find something that we can divide it by. And all you have to do is once you find 1, okay, you can use synthetic or long division to help you find the others, okay, by breaking that polynomial down. Okay, and again, repeating, when you do this p over q, so the last number is the q and the p, and the first number is the q. Those are the only possible rational roots. So if none of them work, you do not have a rational root. Okay, which means you're only going to have complex roots. Okay. So in this case, 2 would be the one that works. So then you would use synthetic or long division to help you break it down. Irrational root theorem. The irrational root theorem says that if you have a root of a polynomial that is irrational, so it has a square root, so a plus the square root of b, there must be another one that is the conjugate of it, which would be a minus. That's why if you remember our answers, we always put, whenever we had roots, we would go plus or minus, like plus or minus 3. We have a positive 3 and you have to have a negative 3. So if you have one root that's positive, you also have the same, you have to have the same root but negative. Okay. You always have them paired up. So if you have one root that's a square root, you have to have another one. Have to. This is also true with imaginary numbers. Okay. This is also true with imaginary numbers. If you have a minus I, you also have to have a plus I. If you have an answer of I, you must have a negative I as a root. Imaginaries, you have to have only even numbers. Rational roots, or irrational roots, you have to have an even number of those. So that has to be, 2, 4, 6, or 8. You can't have an odd number of those. Rational roots, like the whole numbers, 6, 4, 3, you can have any number of those. Okay, so what you're going to do here is you're going to find all possible roots, or list all possible roots, and then find all the roots for each of these. So you're going to do that p over q and write out every single one that it could be, and then find the roots that there are. Okay, all right.